In this video, I'm going to talk about the impact of optical illusions, such as if you want to show an open gate, a picket fence, or a stone wall, the architectural changes that the ancient Greeks made to counteract these illusions, and many other implications of illusions. In this first illusion, the incomplete squares here are as long as the space in between them, but the space looks smaller because we assume that these open-ended squares continue off the page. So the illusion is due to our assumptions. And this, for example, could represent an open gate. In the second illusion, this divided space appears longer than the solid rectangle, even though they're the same length, because it is busier with more divisions. And as you add divisions, the space seems to expand. So this could be, for example, a picket fence, and this could be a stone wall. Now this one is sort of amazing to me. The middle circle here is as big as the middle circle here, even though this one looks much smaller. And I have the two of them here so you can see that they are actually the same size. So it shows you the great power of contrasts. It looks small next to a lot of large circle, and large next to a lot of small circles. Here are some optical illusions involving perspective, and you can see that they all have converging lines. So let's start with this first one. This horizontal line looks longer than this one down here because we expect it to be shorter since it is next to these converging lines. This box looks bigger than the rest, even though all the boxes are the same size, because we expect it to be smaller because it's higher on the page within these converging lines. And this line A looks longer than line B because we expect it to be shorter. But look what happens when we turn this around 90 degrees. Now the illusion isn't as obvious because we tend to follow converging lines upward rather than sidewards. This famous triangle shows closure, meaning that we see the white triangle here, even though some of its edges are missing, like here. But what's even more amazing is that this white triangle in the middle looks actually whiter than the background due to its value contrasts with these black shapes. Although these circles are the same size, this first one looks smaller, and some believe that we're following the arrows so that we think that it's shrinking. But we get the same illusion if we didn't have arrowheads. I think what really is happening is that this overall is a smaller shape than this. The illusion in this chessboard is that value A is the same as value B, and I put value A here, and believe it or not, this is value B. I just copied it and put it over here. The reason it looks different, they look different, is that value A is compared to a lighter value C, whereas value B is compared to a darker value, which is D. And this actually shows the way shading should look. The value contrasts are smaller in the shaded area here than they are in the light area. And the value contrasts in the shade are all darker than in the light area. Here are some examples of pairing of two shapes and how it can affect the design. So in this first one, the left side of the square seems to shrink since it's in a large space and expand over here in a small space. Similarly, this rectangle looks narrower here than it does over here. Now, when you have two lines where one of them is vertical, you sort of lose the vertical relationship here when you have two lines that are nearly the same. The ancient Greeks altered their architecture to counteract optical illusions, so this horizontal line seems to sag in the middle. And the Greeks made their treads on stairs curve up to compensate for this apparent sagging. Similarly, columns seem to cave in the middle. And so the Greeks intentionally bowed them out to counteract that. And this is called enstasis. A bad column is drawn with a ruler, while a good column seems animated if it swells out a little bit. This compressed pattern results in a much greater sense of space than converging lines alone. And it's more powerful if it's geometric like this one is, rather than having an organic pattern. And it triggers a survival instinct. In other words, infants and kittens wouldn't walk across this for fear of falling. These are examples of after images, or things you see after staring at a pattern. So if you look at this pattern for a while, you'll see little black squares at the intersection. Here you'll start seeing little dots in various places, and here the lines will seem to wiggle. Now, if you concentrate on one of these intersections, then the little black square seems to go away. This is the Necker illusion, which is a cube where we vacillate between looking at it from a worm's eye view looking up or a bird's eye view looking down. And why is that? Well, we usually look at cubes from a bird's eye view. So the front for this bird's eye view has a light line because it doesn't need to be emphasized. We always already look at it from that viewpoint. And actually, these light lines cross the dark ones in back, consistent with the bird's eye view. But what's not consistent is that these sides diverge a little bit, but we don't quite notice that because we're used to looking down at things. Now, how can they make us look up at this cube? Well, to do that, the front has a much darker line around it, and the sides either are parallel or converging, consistent with the worm's eye view. Remember my book on Amazon, Ellen's Guide to Design Elements, and please remember to subscribe.